Hello, everyone, and welcome back. So, today we're going to be looking at solving some rational equations. And for terminology purposes, when we say to solve a rational equation, everything we said about polynomials previously with respect to their solutions applies here. So, as a reminder, this still means we set this thing equal to zero to figure out which values of x satisfy the equation. And depending on the circumstance, it still means to find the x-intercepts. And I wanted to include this example because these were previous ones that we've actually had a look at before, and I just wanted to make a small distinction. Okay, so we're going to solve the following. I didn't leave a lot of room because we won't need a lot of space. So here, x minus 2 over x minus 3 is equal to 0. So we know that from these earlier, the first step we would do is just multiply both sides by x minus 3. But 0 times anything is going to be 0. So this will be x minus 2 is equal to 0. So x is just equal to 2 is our solution here. Okay, so just as a reminder, if your equation looks like this, whereas it's like something over something is equal to 0, the denominator can be eliminated. It should be noted here that we want to be careful insofar as is that sometimes we might have a cancellation in the numerator and the denominator. So we just do a quick check to make sure that the solution isn't something like a vertical asymptote or something, which means then we could have canceled it out. Okay. What about B? We have here x plus 3 squared over x minus 1. So here, multiplying both sides by multiplying both sides by x minus 1, we have x plus 3 squared is equal to 0. So we can just make this stipulation here that x is equal to negative 3. And it doesn't matter that it's going to be x plus 3 squared. Since we're within the context of solving the solution, we don't need to mess around and say multiplicity 2 or order 2. Okay. And again, we make a small note here, and we notice the case that x cannot equal 1 because we don't want to accidentally include a solution. Okay. This last one here, we have x minus 3 times x minus 1 divided by x cubed plus 1. Okay, so setting the numerator equal to 0, we find that our solutions here will be x is equal to 3, comma 1. And we just have the restriction that x cannot be equal to negative 1 because negative 1 cubed is negative 1 plus 1 will give us 0. And so for now, let's have a look at some more tougher examples of rational equations. So let's get started with two examples we might have been able to solve in the past. So here we have uh, x minus 3 over top of 10 is equal to 4x. So the goal here for solving these things generally is we want to eliminate denominators. Okay, so here, how do I get rid of this dividing by 10? I would multiply both sides by 10. Okay, so this 10 and 10 go away. And what I'm left with is x minus 3 will be equal to 4x times 10 is 40x. Now I'm going to minus x from both sides. Ooh, that is like the worst looking 4 I've ever seen. There we go. Minus x from both sides. I get negative 3 is equal to 39x. Dividing both sides by 39 yields negative 3 over 39 is equal to x, otherwise known as negative 1/13. Now, I wanted to be very particular with how I solved this, okay? Because your first instinct over here is gonna be correct, but I just want to caution you to say that when we eliminate denominators, we multiply both sides by whatever the denominator happens to be, okay? And so here for B, there's a term that you might have heard of before called cross multiply. It's not my favorite term, And so here, it'll work in this case, but it won't work in the next example. So that's why I want to exercise a little bit of caution. Okay, so how do we solve this thing? Well, this is x plus 3 over x minus 4 is equal to x minus 1 over x plus 2. So to eliminate the denominator, what we want to do in this case is multiply both sides by the denominators x minus 4 and x plus 2. So what happens when we do this? Well, if you notice, on the left side, the x minus 4 doesn't survive, and on the right side, the x plus 2 doesn't survive. So what we're left with will be x plus 2 multiplied by x plus 3 is equal to x minus 1 times x minus 4. Okay, so some people, and I know the natural instinct is to say, hey, the x minus 4 goes up here, the x plus 2 goes up there. This is completely true. But again, the next example will illustrate, because if we have additional terms, this pattern breaks down. Okay, so let's expand this out. This is a normal two binomials. So let's have a look. This will expand out to be x squared plus 2 plus 3, 5x, 2 times 3 plus 6. X times x is x squared. Negative 1 plus negative 4 is negative 5. X, negative 1 times negative 4 is positive 4. And now this has been reduced down to a polynomial that we learned on the lesson of a couple of times ago. So we're going to minus this all to one side. So x squared minus x squared is 0. 5x minus sine negative 5x will be 10x. 6 minus 4 is 2. Okay, so we can now solve these. Plus 2 on both sides. Divide both sides by a 10. And 2 divided by 10 reduces to 1/5. You could have saved yourself a little bit of time by moving the x's over to the left side and then moving the constant over to the other. But in truth, it doesn't matter too much. So here is our solution. The only thing now is we check to see if this didn't happen to be a vertical asymptote or some kind of hole in the function. And we can see here we have two restrictions. X cannot equal 4 and negative 2, meaning that our solution is of 1/5 will be a solution for this equation. And so now we wish to solve a more complicated question. So last time it seemed like we were able to kind of quickly spot a pattern, and I hope that we can also extend that idea of the pattern. So here we're going to solve x minus 2 over x plus 3 is equal to x minus 4 over x plus 4. But we're going to write the minus 1 afterwards, because I wanted to leave a little bit of space because I'm going to multiply both sides by the common denominator. So here we are going to multiply both sides by the common denominator, CD, which will be equal to x plus 3 times x plus 4. But now when I say both sides, that actually means that we're going to end up multiplying out 3 terms. So it'll be x plus 3 times x plus 4 onto 1, 2, and 3 terms altogether. And so let's write that in. So here it'll be x plus 3 times x plus 4, another x plus 3 times x plus 4, and here x plus 3 times x plus 4. A small note of caution, sometimes when people write this out, they write this as x minus 4, and then it's just the negative 4 is multiplied. We're saying that it's the whole thing in the numerator for clarity purposes. Okay, so here what survives on the left? Well, the x plus 3's don't. So we're left with this x plus 4 times x minus 2. On the right side, the x plus 4 cancels out or reduces down to 1. And so we're left with this x minus 4 times x plus 3. And there's nothing that cancels out with this with this -1. So we're just left with this result. So it'll be minus sign -1 times x plus 3 times x plus 4. Now we just have to clean this up. So here, x plus 4 times x minus 2, that'll yield x squared. 4 minus 2 is positive 2 of the x variety. 4 times -2 is -8. X times x is x squared. -4 plus 3 is -x. -4 times 3 is -12. And over here, we've got x times x is x squared. 3 plus 4 is often 7 of the x variety. 3 times 4 is 12. Now, I do want to extend a caution for us at this point. It is pretty easy to start making little algebra mistakes when you do this. And so after you go through all of this, it's always a good idea to check your work, or either by checking the solution or by either checking the solution or just graphing to make sure that this makes sense on Desmos. Okay, what happens next? Well, we can do one of two things. We can either expand out this negative onto the polynomial quadratic and then simplify afterwards, or we can do two things where we can simplify this by combining the terms here and then expanding this out. I'll leave the choice up to you which we do, but for now, I like to do just one kind of big step at a time. So we'll expand out this negative. So rewriting this out, x squared plus 2x minus 8 is equal to x squared minus x minus 12. And now all of these signs get flipped because it's negative minus all of this. So minus x squared, negative minus 7x minus 12. So from here, we do notice that one of our terms will not survive here on the right. We have an x squared and a negative x squared. They go away. And so combining our like terms on the right side, negative x minus 7x is negative 8x. Negative 12 minus 12 is minus 24. Okay, so from here, we want to combine our terms on the right over to the left side. And so here, what this will yield will be x squared. 2 plus 8x is 10x. Negative 8 plus 24 is positive 16, which is equal to 0. And now we must play the most dangerous game. What two numbers multiply to make 16 and add to make 10? Those numbers will be 8 and 2. And so what we'll be left with is the case that x must be equal to -2 comma -8. And so we do a double check up here to make sure that those were not one of our restrictions. And we do note that for our restriction purposes, x cannot equal -3 comma -4, which means that those will be our solutions. So now we're interested in solving this 1 over x plus 1 over x squared is equal to 2x. So we're going to employ the same strategy as before by multiplying by a common denominator. So here, we're interested in eliminating this denominator, and this time they have some similarities. We've got an x and an x squared here. So x squared will actually will work for both. Why? Well, x squared divided by x is just x. X squared on x squared is just 1. So that's why we're going to multiply both sides by the x squared. Okay, and so here was the step when previously I said we multiply every term by the common denominator. And explicitly, this is why this is the case. Suppose you have 2 or more terms separated by plus or minus signs. When you quote multiply both sides by the common denominator, it's going to be just x squared times everything else inside of a bracket. So in this case, here, 1 over x plus 1 over x squared. So we expand out this x squared onto both terms. So here, this will yield x squared on x plus sine x squared on x squared is equal to 2x cubed. Okay, and so these are the steps that I'm showing just to make sure you understand like the algebraic simplification process. Okay, so x squared over x is just x. X squared on x squared is just 1. And this will be equal to 2x cubed. So here, I like a positive leading coefficient, so I'm going to move the x plus 1 over to the other side by subtracting them. And so this will be 0 is equal to 2x cubed minus x minus 1. And this has now been reduced to a polynomial that we have solved on the lesson of last time. And so to factor this, we will need to use synthetic division. So we ask ourselves the question, what are some factors of -1? So we'll need to check combinations of plus or minus the constant 1 over the numerator 2. So this was the rational factor. This was the rational portion of the factor theorem. So here, by inspection, though, if x was equal to 1, 2 minus 1 minus 1 would give us 0. So here, since p of 1 will be equal to 0, x minus 1 is a factor. So we'll put the restriction in here, 1, and we'll put the coefficients of this thing. So it'll be 2, there's no quadratic term, so we'll put a 0, -1, and another -1. We will invoke large multiplication and big addition. So the 2 comes down. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. -1 plus 2 is 1. 1 times 1 is 1. We end up with a 0. So this will factor to become this x minus 1 times this thing. So this is so since we took our cubic and divided it by a quadratic term, by a cubic term, we'll have a quadratic left. So this will be 2x squared plus 2x plus 1. And so note, now we got to factor this thing. I don't know what two numbers multiply to make 2, but add to make multiply to make 2 and then add to make 2. So I must use the quadratic formula. So note that this is going to be a is equal to 2. I suppose I can write this right above my work over here. A must be equal to 2, B is equal to 2, and C is equal to 1. So here we will have the case that x will equal -2 plus or minus the square root of b squared. So that's going to be 2 squared minus 4 times a times c over top of 2 times a. So x will be equal to -2 plus or minus. Okay, so this is going to be 4 minus 8. So this is going to be -4 over 2. And here we've already seemed to have landed on a problem here. We work in real numbers, and so what we've landed on is something called a complex number, the square root of -4. And so there's nothing more we can do here. And so this portion cannot equal 0. It has no solutions in real numbers, although it does have complex ones. So here, therefore, we actually have only one solution to this. So therefore, x is equal to 1. And we note we kind of have we check back to the beginning just to make sure that this doesn't appear to be a problem. And note that the only restriction we had here was x actually just is not allowed to be 0. So x equals 1 is a solution. This one I don't mind checking with us because this is 1 over x and 1 over x squared. It should be equal to 2x. So this is essentially 1 plus 1 does in fact equal 2. So similar type of question that we saw from before. But again, I have found that usually when it comes to solving rational equations, the hard part is usually getting started, meaning the initial elimination of the common denominators. And then from there, the most common mistake tends to be just some small algebra things, such as saying like -3 plus 4 is like, say, 7 as an example. So here we invoke the same strategy as before. So we want to multiply by the common denominator. Well, what's that going to be? Well, we need at least an x because both of these have an x. We also will need a 5 because this will have a 5 as well. So we need 5x. And then we need this x plus 2. So what will eliminate all the denominators will be 5x times x plus 2. And that's what we will multiply onto both sides. Okay. And so remember, we expand this out then. So what happens next? Well, from here, the x plus 2, this x plus 2 will cancel with the x plus 2. And so that these will go away. And what we're left with will be 5x times 3. And on your own, you can just write this as 15x. But again, for review purposes, if you want to look at the video later, all I did was eliminate the x plus 2s, and this was what was left over. What happens here? Well, the x part of this goes away, and what we're left with is minus sign 5 times x plus 2. And this is equal to what? Well, these 5x's go away, and what we're left with here is just another x plus 2. And so now we can go ahead and clean this up. So 5x times 3 will be 15x. Negative 5 times x is going to be negative 5x. Negative 5 times 2 is negative 10. And this will be equal to, say, this x plus 2. Combining some of our terms together here, we've got negative 15x minus 5x, so that'll be 10x. Minus 10 is equal to x plus 2. So we're going to move the 10 over to the other side. So by adding 10 on both sides, so 2 plus 10 will give us 12. We will minus x from both sides. So 10x minus x will be 9x. Dividing both sides by 9, x will be equal to 12 over 9, which reduces to 4 over 3. Okay? And note, the only restrictions that we had here from the start, because we want to confirm that the answer we found didn't happen to be a solution. So here, we have a restriction such that x cannot be equal to negative 2 and 0. So for here, we only have one solution to this equation.